Chapter 5 Investigating Motion. Finding a store in a shopping mall and driving a friend to a friend's house are tasks that you might do without any thought. You might not think about motion when you do tasks like these, but these tasks involve motion and describe motion. List some words that describe motion. Think about it. Maybe you said left or right. Speed, velocity, acceleration, direction, fast, slow, describing motion. Telling someone how to get from one place to another, such as from their home to a movie theater, is an example of describing motion. Question: how would you describe the location of the woman holding the purse on the left side of the photograph relative to the man in the bow tie behind the counter? Think about it. Well, one could say she is in front of him. He is behind her. She is to his right. He is to her right. They are approximately 2 meters apart. Position. When you describe the position of an object, you must include the distance, the direction, and a reference point. Distance is a unit of length, and the SI base units for length is meter. Compass points, or plus and minus, if you're using a number line, are used to describe direction. Number lines in coordinate systems are often used to specify position. What are 2 ways that you could describe the position of the skater on the right? One thing we could say is the position of the skater is positive 9 meters. From the fire hydrant. We also could say the person is 9 meters east of the fire hydrant. Position. Motion is a process of changing position. 2 ways of describing motion are distance and displacement. Displacement is the distance of a straight line distance, or the difference between the initial, your start, and your final finish of an object. Question: what distance did the players run in A, B, and C? What displacement for each? Pause the video and have a look. A. Our distance is just 27.4 meters. Our displacement is the same. It's 27.4 meters. B. B. Here we have a distance where I need to add my 27.4 plus my 27.4. So my distance here is 54.8 meters. My displacement, however, is the distance from my starting point to my finish point. So this would be 38.7 meters. Now if we're looking at C, we're going all the way around. I would add each one of these up for my distance. So my distance would be 109.6 meters. Whereas my displacement equals 0 meters. Because my starting point is also my end point. Scalar quantities and vector quantities. Scalar quantities is a quantity that has only magnitude, which is size, and is represented by a number and units. Scalars are distance, time, temperature, whereas a vector is a quantity that has both magnitude, size, and direction. Displacement and position are both vectors. Arrows are often used to represent vectors. The length of the arrow represents the size of the motion. The arrow point represents the direction of the motion. What is the runner's displacement in the figure below? Think about it. So when I look at his initial, it's at 10, and its final is 50. So its vector quantity would be 40 meters east. And this is a vector quantity. Calculating displacement. Displacement, meaning the change in position, is represented by the equation below. So here we have delta D. Remember, the triangle means change in. So delta D with an arrow means change in position. Then we have just D with the arrow on top, which means our position, and it's measured in meters. DF or D2 with the arrow on top means final position, and it's measured in meters. DI or D1 with the arrow on top means initial position, and it's also measured in meters. Section Review 5.1. When you describe the position of an object, you must include a distance, direction, and reference point. Units of length, such as meters and kilometers, are used to measure distance. Compass points and coordinate systems are often used to describe position. Two ways of describing motion is the process of changing position, our distance and displacement. A scalar is a quantity that has only magnitude, such as distance, time, and temperature. A vector is a quantity that has both magnitude and direction, such as displacement and position. Vectors are used to represent motion, and they are added to the final resultant vector.